Hello and Assalamualaikum. Welcome to our project video presentation for assignment 4, Reservoir Fluid Properties. To begin, let me introduce our group members. Dini Haikal, Muazzam, Ashraf, Fawaz and myself, Nur Hazrin. This video will cover 3 main points. For the first one, PVT concept. Second, PVT report analysis. The last one, summary. Let's go started. Let's go!
PVT concept. Okay. PVT concept. P, pressure. V, volume. T, temperature. These are the 3 main variables that describe the behavior of reservoir fluid. So, why is it important? So first, PVT concept helps us, petroleum engineers, to predict reservoir performance. And second, to help assist us to know the best enhancement oil recovery technique to extract the oil. And lastly, to estimate the recoverable hydrocarbon that we can extract from the reservoir. What did I learn from our PVT lab trip? Okay, let me explain. So, during our PVT lab, the lab guy did explain on PVT analysis. The key elements to find from the analysis is composition expansion, viscosity, bubble point or dew point, and also separator test. And next, the lab guy also explained the PVT cell. The PVT cell looks like my refrigerator at home, but what that lab equipment help us? So first, the equipment was used to examine the behavior of fluids under varying pressure, volume and temperature. And after that, it will undergo spike flash test, which is the test is used to determine the flash point of the fluid, which is the lowest temperature at which a liquid can produce enough vapor to ignite when exposed to a source of ignition. Boom.
Hello, my name is Muazzam bin Samsudin and I will be presenting the part of report analysis. So for the report analysis, we will be using 2 samples. So for the first sample code is 101335559 and the second sample code is 101697003. So I will be present for the part A and the part B. So we go to the part A first. We need to determine the saturation pressure of this fluid sample. So we can determine the saturation pressure of this fluid sample by using 3 ways. So for the first one, we are using the constant composition expansion, which is CCE test. And the second one, we can use the correlation of Westphalia index. And the last one, we can use the Excel plugin. So the result of when we are using the constant composition expansion CCE test is we get the saturation pressure of 2648.35 when we do the intersection between the 2 trends of the graph. So next, when we are using the correlation of Westphalia index, we get the result of 2672 psia. And the last one, when we are using the Excel plugin, we also get the result of saturation pressure, which is 2672 psia. So this is for the part A for the sample code 101335559. So it same goes to the sample code of 101697003 that we need to determine the saturation pressure of this fluid sample. So we also use 3 ways, which is CCE test, correlation of Westphalia index, and the Excel plugin. So for the CCE test, we get the result of saturation pressure, which is 3056.15 psia. And when we are using the correlation of Westphalia index, we get 3086 psia. And also when we are using the Excel plugin, we get the result of 3086 psia. So why there is the difference between the value of each weights when we are using to determine the saturation pressure. So the first one, when we are using the experimental method, this method is most accurate because it reflects the actual reservoir fluid behavior, and the volume reading accuracy have lots of accuracy. And now we move on to the part B. For the part B, we need to calculate the oil compressibility of the sample as shown in the report, and also we need to repeat the calculation pressure above and below bubble point by using correlation and also X-line. So we have the oil compressibility that have been stated in the report, and when we need to determine the oil compressibility by using the correlation, I have stated the formula for above bubble point and the below bubble point, and also I have stated the plug-in formula that can be determine the oil compressibility. So as we can see in the slide, so this is the result of oil compressibility that I have calculated using correlation of Pascal's and Beck's plug-in and also the measured data. Now we will move on to the oil compressibility graph for above bubble point and below bubble point for the sample 101335559. So we see the left side first, which is the above bubble point. As you can see, there is 3 lines, which is the blue one is for the correlation, the orange for the plug-in, and the grey one is for the measured data. And we can see the observation is compressibility is increased significantly as pressure decrease below bubble point. And now we will see the right side for the below bubble point, oil compressibility below bubble point. And as we can see, there is no measured data that have been recorded, but we have the correlation and the plug-in data, and it seems like the first observation, which is compressibility increases significantly as pressure decrease below bubble point. We also plot the graph of oil compressibility above bubble point and below bubble point for the sample 10169,703. And for the left side, as usual, is for the above bubble point, and the right side is for the below bubble point. And as we can see, for the blue line is for the correlation, and the orange one is for the plug-in, and the green one is for the measured data. And the observation for this graph is same like the sample of 10 before this 101335559, which is compressibility increases significantly as pressure decrease below bubble point. And same goes as the below bubble point, there is no measured data of oil compressibility has been recorded. We only have the correlation and plug-in data. So the observation is still same. Compressibility increases significantly as pressure decrease below bubble point.
Hi everyone, I'm Daniel, and I'll be going over question C and D of our QT report analysis. Let's begin with question C. For the first sample, the optimal separator conditions is as follows: pressure at 65 psi, temperature at 97 Fahrenheit, and API 44.23. All of this data can be directly taken from our QT report. To convert specific gravity to API, we need to use these formulas: 141.5 divided by specific gravity minus 131.5. The optimal separator bubble point solution GOR is 639 SCF over STB, while FEF is 1.362 res BBL over STB. For the second sample, the optimal separator condition is as follows: pressure at 65 psi, temperature at 97 Fahrenheit, and API 40.77. All our data can also be directly taken from the PVT report. So for the optimal separated bubble point solution GOR is 694 SCF over STB, while the FAF is 1.399 BBL over STB. These are the conditions that give us the most useful and reliable fluid behavior for reservoir simulation and production forecasting. Let's move on to question D, starting with the first sample. As for the VO, we can use these equations to calculate the measured data from the PVT and also the correlation from Vasquez and Bax below PB and also above PB. As for the VO graph, it increases with pressure until it hits the bubble point. That's because dissolved gas expands the oil volume at P equal to 2672 psi. BO reach its maximum. Beyond that, as pressure increases, oil slightly compresses, so BO slightly decreases. Right, next let's look at the RS. We can use this correlation equation to find the value for the correlation part. Also, according to our PVT data, the bubble point pressure is 2672 psi. At pressures above bubble point, RS remains constant at 639 SCF over STB. All methods measured Vasquez and Bax and Dzulkarnain agree on this saturation value. So why this happen? Because once pressure is above PB, no more gas can dissolve into the oil, so RS stays flat. Now, below the bubble point, RS decreases gradually as gas comes out of solution. All three methods follow a small downward trend, with the measured values capturing the behavior most accurately. Next, we have the second sample. For BO, the pattern repeats. BO rises with pressure up to 3086 psi, then slightly falls as pressure continues to increase due to oil compression above PB. It behaves similarly but with a higher bubble point pressure of 3086 psi. RS just constants at 694 SCF/STB above the bubble point pressure, and just like before, all three estimation methods align at this value. Below this bubble point, RS decreases as pressure drops, following a similar trend to the sample 1. The measured values again show the most detailed behavior.
Hi, this is the summary part for integrating PVT lab and PVT analysis. So the bubble point pressure in the PVT lab, we conduct the CCE test by a fluid sample charged in high pressure and kept it in reservoir temperature. Then the pressure gradually decreases while keeping the fluid composition constant. At each step of pressure, the volume are recorded. So at the PVT analysis, we plot the volume change that we get from the PVT lab as pressure. So there will be like two lines we get, and the intersection is the bubble point pressure. So we also calculated using the correlation of Vasquez and Bax, and we get the same value. For the oil compressibility, at the PVT lab, we conduct CCE test where the fluid sample placed in high pressure, and then we brought it to the reservoir temperature, and then the temperature is decreased step by step to get the volume for each pressure. And then we conduct differential liberation test for pressure near the bubble point and below the bubble point, because the composition of fluid change as the liberation of gas. So from this we get the formation volume factor, and then from the formation volume factor we can use the formula given, and then we can calculate the oil compressibility. For the PVT analysis, we use correlation Vasquez and Bax to find the compressibility oil above and below, and then we plot a graph for the measurement taken for PVT lab and the correlation, and then the graph for pressure above and below is separated as we use the different correlation. For the optimum separator condition, from the PVT lab, we conduct the flash separation test by varying separator temperature and pressure. The optimum separator pressure is where the formation volume factor is maximized. At the PVT analysis, we use the correlation request and batch where the pressure, temperature and api gravity measurement taken from the PVT report. Lastly, for BO and GOR, at the PVT lab, we use differential liberation test to know the volume of gas liberated. So, we can find the BO and GOR using the formula given. And then, for PVT analysis, we plot the GOR and BO US pressure using the value we get from the PVT lab. So that we also use the correlation request and that to find BO and GOR for each pressure and plot the graph and then compare it to the measurement taken from the PVT lab. What we learn from this assignment? So first, we get to analysis the real PVT data, and then we get to know the process of PVT lab, which is from the PVT lab visit, and then we get additional knowledge using Excel when we use plugin to get the data. And then fourth, we can use the correlation equation from the side note, which is we mostly use vectors and batch. Lastly, we can integrate between PVT analysis and PVT lab. That's all from our presentation. Thank you for watching.